Good evening and welcome. Tonight we're going to be looking at the stars in the night sky in December. My cat's over here trying to get on the desk. He knows he's not supposed to while I'm filming, but anyway, he just wants a warm lamp to sit in, that's all. He's a good cat. Anyway, this is the last video in this series. Very sadly, I'm gonna miss it. I'll definitely have to do more monthly space-themed videos in 2022, but let's just get into it. We'll start with the Northern Hemisphere stars, then we'll go into the Southern Hemisphere stars. We'll look at a constellation in the night sky, and then we'll learn a little bit more about space. So let's start in the Northern Hemisphere. It says the W shape of Cassiopeia makes it one of the easiest constellations to recognize. It is almost overhead at this time of year and acts as a useful signpost to other constellations. I can see it already. Cassiopeia. It's a big Cassiopeia. Follow the points of the W southward. South, this way. It says go past Andromeda, right here, her mother, and you come to the three main stars of Triangulum. Right here, Triangulum. Continue in the same direction until you see another pattern of three stars. These form part of the zodiac constellation of Aries the Ram. Oh, right here. So let's read more about some of these constellations, starting with Cassiopeia. The cat hair everywhere, sorry. This constellation represents the vain queen Cassiopeia grooming her hair. Oh, I had it backwards. Cassiopeia is the mother, Andromeda is the princess. My apologies. Traditionally, her figure is shown circling the pole upside down. The Greek myth said she was punished for her vanity. The Milky Way here is rich with stars and star clusters and is ideal for scanning with binoculars. Here is Aries. In Greek mythology, Aries the Ram was renowned for having the golden fleece prized by Jason and the Argonauts. Its star Gamma is a wide double star which is easy to split into two when viewed with a small telescope. Found in 1662 by English scientist Robert Hooke, Gamma was one of the first double stars ever to be discovered. Can we tell which one it is? Probably this one. It's really big. And here's little Triangulum. Triangulum gets its name, wait for the shock and surprise, from its shape. It is not a bright constellation, but its three main stars make a distinctive pattern that is not too hard to spot. The ancient Greeks also saw it as the letter delta, which is shaped like a triangle, in their alphabet. Scan this area with binoculars and you are likely to alight on a misty patch, a nearby spiral galaxy. Speaking of spirals, I'm going to miss the sounds of the spiral-bound book. I'm going to have to find some other book with spiral-bound anyway. Flip this over to check out the Southern Hemisphere. Here we go. Very carefully. And here we are. The Southern Hemisphere stars. Let's see if I can navigate this sky. The south polar region of the sky is home to the Large Magellanic Cloud, or LMC, in the constellation Dorado. I can see the cloud before I see Dorado. There it is, Dorado. Large Magellanic Cloud. And the Small Magellanic Cloud in Tucana, right here. Small Magellanic Cloud, there's Tucana. These galaxies are easy to find in clear, dark skies. Look east of the LMC to find Hydrus. East of the LMC. West, east, Hydrus. Let's see. Hydrus, there we go. Hydrus. And to its south to locate Octans. Octans right there. This part of the sky was unknown to the early sky watchers of the northern hemisphere, so its constellations are more modern inventions. Here's Tucana. The stars of Tucana represent a toucan, a South American bird with a large beak. This is home to the small Magellanic Cloud, the smaller of the Milky Way's two satellite galaxies. I think that must be it right there in this picture. Also here is the spectacularly bright globular cluster 47 Tucanae. Oh, maybe that's 47 Tucanae. It's right next to the cloud, so maybe that's Tucanae and that's the cloud. That makes more sense. Here's Octans. This constellation depicts an octant, which was a device used by sailors and astronomers to measure star positions. Octans contains the south celestial pole, around which the southern sky appears to rotate. That's interesting. And here's Hydrus. This 16th century constellation is known as the Little Water Snake. Do not confuse it with the much larger water snake Hydra, which featured in Greek legends. Hydrus lies midway between the small and large Magellanic Clouds, and so it is not difficult to find. That must be the small Magellanic Cloud, because there's the globular cluster, right? Cool. I'm learning a lot about the southern ice continent. Did you know? Let's learn more. Globular star clusters like 47 Tucanae are made up of some of the oldest stars in the galaxy. 47 Tucanae is about 10 billion years old, twice the age of the sun. Although it appears circular, the SMC is actually in the shape of a cylinder. The gravitational pull of the Milky Way has distorted it. That's pretty interesting. Alright, let's learn about a constellation. First of all, check out this photograph. This is, it'll tell us on this page, but this is the Pleiades. A really, really amazing star cluster that you can see with your own eyes. So let me flip this carefully. And let's learn more about Taurus. So here's the constellation over here. Up here's the Pleiades from the picture. It's a very large constellation right next to Orion. Taurus. The most northerly constellation of the zodiac, Taurus the bull features in legends involving the god Zeus. He transformed himself into a bull and raised his two front hooves out of the sea to kidnap Princess Europa. This is why only the front half of the bull appears in the stars. Hey, Rooster. This constellation has two very prominent open clusters. On the bull's back is the beautiful star cluster, the Pleiades, or M45. It is also known as the Seven Sisters, named after the daughters of the Greek god Atlas. Lying close by the Pleiades is the V-shaped cluster, the Hyades. Both of these magnificent clusters are visible with the naked eye. Here's Theta Tauri, it says, in Hyades, a double star right there. That's neat. Here we can see the Crab Nebula M1. If you remember my earlier videos, probably one of my favorite people involved in astronomy was Charles Messier, and he named the Messier object. So this is Messier object number 1, the Crab Nebula. One of the most famous objects in the sky, the Crab Nebula, is surprisingly hard to see because its light is spread over a considerable area. In the year 1054, a star in this spot exploded as a supernova. The Crab Nebula, a tangle of glowing gas filaments, is its remnant. At its center is a faint blue star that seems to flash on and off at an amazing 30 times a second. Wow. The star is a dense neutron star or pulsar, only a few miles across. It's right here. It talks more about it in this box over here, but let's read about Aldebaran and Hyades. At a distance of 150 light years, the Hyades is the nearest star cluster to us. It has around 200 members and is about 15 light years across. Its stars are loosely scattered in the shape of a V, outlining the face of the bull. Shining brightly among them, the orange giant star Aldebaran marks the bull's bloodshot eye. However, Aldebaran is not a member of the cluster, and it lies only 65 light years away. There's big bright Aldebaran to the Hyades cluster. Let's see it in here. Aldebaran, the Alpha, and the Hyades. Alright, let's read about how a pulsar works. A pulsar is the rapidly spinning ember of a star more massive than the Sun, but not so big that it collapses to become a black hole. Its atomic particles are packed so densely that its electrons and protons combine to form neutrons. Radiation from the star's magnetic poles sweeps around like the beams of a lighthouse. When we are in the path of a beam, we see a pulse of radiation. So here's a diagram down here of the pulsar in the Crab Nebula. When we can't see the pulsar when it's off, the radiation beam going through here, spinning this way. So it turns around like a lighthouse, and the beam's pointing toward us, so the pulsar's on, and then it turns away, and the pulsar's off. Isn't that cool? I didn't really know much about pulsar stars. I didn't know that that was how they worked. That's cool. All right. Did you know? Let's learn some more. The material in a neutron star pulsar is so dense that a sugar cube-sized block of its material would have the same mass as an asteroid 330 feet or 100 meters in diameter. My goodness. When the first pulsar was discovered, its regular radio pulses of about 1 every second seemed like an artificial signal. For a while it was called LGM, an abbreviation meaning little green men. That's funny. All right, let me turn the book again for our very, very last page. Anyway, this last segment I thought long and hard about skipping because it's something that I'm not particularly interested in, which is about telescopes and lenses and all that. But you know what? It's the last video in this series, so why not? Let's learn about telescopes, looking at the universe. Astronomers use a wide variety of telescopes to study the universe. These brighten and enlarge objects by collecting light and magnifying the image. This means that the telescope's most important feature is the diameter of the objective, or main lens, or mirror. Weekly page. When astronomers talk about a 13-feet telescope, for example, they mean the mirror is 13 feet, or 4 meters in diameter. The larger the mirror, the more detailed images the telescope can provide. By using specialized forms of telescope, astronomers can also explore the X-rays, radio waves, and other radiation from astronomical bodies. So let's start off with standard binoculars. Most stargazers own binoculars, which are basically 2 telescopes of low magnification joined side by side. They are easy to carry, and both eyes can view the sky instead of just one, as with the telescope. A typical pair of binoculars can enable the user to see about 200 times more stars than is possible without them. So let's see, that's where you look in. There's the lens. So you look in, the prism light bounces off of here, goes to the objective lens. Okay, anyway. What I really liked about this page that made me decide to read it is this cool thing here. So this is the Whirlpool Galaxy M51 in Canis Venatici, and this is what it looks like if you look at it through a binocular. It looks let's move on to this one is a amateur telescope, a refracting telescope. Let me squeeze this over on my tiny desk. There we go. Also called a refractor, this telescope uses a lens to collect light and focus it at the lower end of the tube. There, an eyepiece magnifies the image, with the magnification depending on the power of the eyepiece. Refractors are useful for producing very sharp images. The star diagonal gives a convenient observation position, while the finder provides a low magnification view to help find objects in the sky. So you look through here. The focused light goes out this way, right? Here's the lens right there. It bounces off that way. That's where the light comes in. The refracted light off the lens. And then it looks like this, the same galaxy, the M51 galaxy. Let's take it up a notch and look at the reflecting telescope. So this one refracts light, this one reflects light. A reflecting telescope uses a concave mirror to collect and focus light. Newtonian reflectors like this one are popular with amateurs. Oh, well, this is the one then. Anyway, I don't know. A small flat mirror near the top of the tube reflects the light to the side, where an eyepiece magnifies the image. The mount allows the telescope to point in any direction. I think it is this one. A Dobsonian mount. That's a cool word. Dobson invented this, apparently. So you look up here, you have to like climb a ladder to get up there. And then you look through down to the concave mirror. It reflects off of the secondary mirror. And let's see, so the light bounces off there. Interesting. Yeah, it makes sense. This one you see a reflection of the light, this one you see a refraction of the light. And it would look like this, a large ground-based telescope, right? On a Dobsonian mount. You can see more details. And then, if we really want to zoom in, let me slide this over very carefully. I have my drink over here. I gotta be careful not to spill it. There we go. We can see the Hubble Space Telescope. The Earth's atmosphere disturbs the light coming in from astronomical objects and blurs the view. The famous Hubble Space Telescope is only 7.9 feet, or 2.4 meters in diameter, but it can provide very detailed images because it is in orbit above the atmosphere. It is therefore one of the most powerful telescopes available to astronomers. So the tube in here has a 7-foot mirror in it and digital cameras. It has antennas, solar panels, all kinds of stuff. And then here's the galaxy and the Hubble, from the Hubble. It just details of numerous star-forming areas and the spiral arms. Here's another telescope out in space. It's the Chandra Telescope. Many hot bodies in the universe emit X-rays, so X-ray images help us to understand the violent processes that occur in extreme conditions. I've had some really weird acid reflux issues since Thanksgiving. I think I eat too much anyway. Chandra has a special type of mirror to reflect X-rays, which are then focused and detected in a similar way to light in other telescopes. Black holes, supernova remnants, and galaxies are all explored with the Chandra Telescope. So here's an image from the Chandra Telescope of a supernova within the Small Magellanic Cloud. That's an interesting way to see light. Here's another interesting way with a radio telescope. A huge concave dish is necessary in order to receive radio waves from the sky. It works in a similar way to the mirror in a reflecting telescope. However, instead of an eyepiece, this type of telescope uses a radio receiver. So this is what the Large Magellanic Cloud looks like from a radio telescope. Yellow and red indicate hydrogen clouds. And lastly, we have the Very Large Telescope, which is very imaginatively named. There we go, here it is. 4 separate 27-foot or 8.2 meter reflecting telescopes make up the Very Large Telescope. The site at Cerro Paranal in the Chilean Andes has views of some of the darkest and clearest skies on Earth. 2 or more of the individual telescopes can be linked, so they work together as one telescope of immense power. I wish there was an image of what it looks like from the Very Large Telescope. And lastly, there's a little biography box here about none other than Isaac Newton. Englishman Sir Isaac Newton laid the foundations of modern physics with his great insights into the nature of motion, light, and the force of gravity. In 1669, he made the first reflecting telescope, the forerunner of today's instruments. The design he invented, called a Newtonian reflector, is still used for amateur telescopes. And that's going to be the end of this series. Thank you so much for watching. I hope that you found this video relaxing and educational. Let's hear that again. Oof. It's at the end of the book. Let's go out with some page turning sounds. Might be a little too loud actually for an end of the video. So let me flip a bunch. That's better. Oh, so pretty. Good old Orion. You can see him in the night sky right now. Say goodbye to the night sky atlas. Thank you so much for watching. I hope you found this video and this series relaxing and educational. And I hope you have a very good night. Good night.